Hello and welcome to the session, Grappling with Massive Data in the Public Sector. My name is Matt Bichelle, Head of Product Marketing here at Aerospike, and it's my pleasure to introduce both speakers for this session. John Dillon is currently the chairman of the board of Aerospike, where he previously held the role of CEO for the prior 7 years. He's got more than 30 years experience in high-growth tech companies. He's previously the CEO of Engine Yard, Hyperion Solutions, Navis, and yes, Salesforce.com. He also was an engineer at EDS and held sales management roles at Oracle in their relational database division and helped grow them from 100 million to $1 billion. John attended the Naval Academy, was a former submariner retiring with the rank of commander, and currently serves as a director of the Naval Academy Foundation Board of Directors. Bob Flores is CEO and founder of Applicology, and he's a former CTO of the CIA. While there, Bob held positions in the Director of Intelligence, Director of Support, and my favorite, and the National Clandestine Service. Bob did many things at the CIA that you might expect a former CTO to do: software architecture, design, development, database design, enterprise architecture, technology assessments. But some other things include econometric and statistical modeling. Overall, Bob was awarded the CIA's Distinguished Career Intelligence Medal, and he holds a bachelor's and masters in statistics from Virginia Tech, and has done even more graduate studies at George Washington, as well as the Kellogg School of Management at Northwestern. So with that, I will hand it over to John Dillon's capable hands to lead this session.
Thanks, Matt. And Bob, first of all, I'd like to thank you for joining us today, and really appreciate the time and attention to this subject that we're all so interested in, and it's data. And after all, you've pretty much spent your entire career thinking about data and figuring out what to do with it. So I think this is very appropriate for a database conference, as it were. And I'd like to ask you a few questions and get you to opine with, if you think back through your 30 years, you've probably seen a little bit of everything. One of the things that we're seeing, Bob, is that companies are dealing with, of course, more data, but also data coming in from a lot of different sources, both internal and external, and trying to figure out how to process it and this, that, and the other thing, how to make sense of it, and then, frankly, how to extract value from it. Are you seeing some of this, and do you have any thoughts about how to manage change with this growing exponential volume of data?
Well, first of all, thanks for inviting me. I'm really honored to be here. And I always enjoy letting people know sort of what's on the top of my head when it comes to things, whether it's about data or a variety of other things. So yes, John, I see this all the time. And we certainly saw it when I was at CIA, saw it not just there, but throughout government. In fact, back in the day when compute was relatively expensive, and the tools were not available to manage lots and lots of data. You were forced to have smaller sized databases. And so that led to having people who were specialists in, whatever data was collected in those databases. So you didn't have the ability to sort of cross-reference things in lots and thousands of different databases. And, I can remember at one point we had, that's well over 100,000 databases that had stuff in them. And no one human being could, manage to go through all that stuff. So, fast forward a bit, and what happened? Well, Moore's Law happened, and compute became much less expensive. Storage became relatively much less expensive. And so now you have the ability to be able to collect massive amounts of data. Well, then what? You had to be able to retrieve this stuff quickly and so on. And so a lot of the database vendors started popping up. And a lot of the old style databases fell out of favor because they were too slow. Some of the old hierarchical things, for example. And so SQL became, the thing. And then you had a bunch of smart folks that said, you know what, we think we can do better than that. So that kind of spawned the NoSQL era, if you will, which is we're pretty much still in. And so yeah, we see this issue all the time. And the good thing is that now that you have tools available, like Aerospike and others, to be able to manage all this data, you now have the ability to understand nuances in the data much better than you ever could before. And so now we can take the person who used to be an expert on Korea and Korean data and the person who used to be an expert on, say, I don't know, France and French data, and those kind of specialties don't matter that much anymore, because now it's just all about the data, and you can create algorithms and machine learning algorithms to walk through that data in a very timely manner to tell you things about the data that you had no clue was even there.
Yeah, that's fascinating. I remember years ago, I was in a competitive situation and I was trying to find the biggest Oracle database in the Western United States. And I found it, and it was 10 megabytes.
Yeah.
So it just goes to show. One of the things that we seem to be seeing in our engagement with the marketplace is the need for very large volumes of ingestion, data ingestion, in a split second. But then on top of that, turning that data around and pushing it back to the edge to be, if you will, valuable or used in a small SLA window for real-time decisioning. With your experience, what are your thoughts about the nature of that sort of, if you will, data usage model, and where do you see that going?
Well, so speed matters. And, some industries, speed doesn't matter. But in a lot of industries, speed does matter. The advertising world, the quicker you can get the ad in front of somebody, especially a relevant ad in front of them, the better off you're going to be. The more chances are you're going to get a click through and therefore be able to monetize that. Speed matters, within the intelligence community, always has. How fast can we process this data and be able to form opinions about it so that we can talk to the policymakers about what we're seeing? Trading floors, speed matters. Even among the banks in being able to process large quantities of transactions, they want to get those things through the system as quickly as they possibly can. So any time you have, all facets of processing the data from ingest to consuming the actual data, whether that's through a human being or through another app, every step of the way, you want to be able to optimize the speed of that transaction. And you have to be able to look at things smartly and say, well, gosh, again, back in the old days, oftentimes we spent a lot of time trying to normalize data. And because that's the way you could take a look at it with the apps we had. Well, given the right apps these days, you don't need to do all that. So you have to think differently about this as well in order to take advantage of the fact that you have tools around that can speed this process up tremendously.
Yeah, that's interesting what you can do today versus what we could only do 5 or 10 years ago, and now it's possible. One of the things that we see is a lot of the data is distributed because the consumer of the data is maybe remote, maybe not in the same geographical location, maybe that distribution's got issues to do with latency or where it needs to be consumed or data provenance. And at the same time, the source of the data can be generated by different parts of the organization. And so we see kind of a tug of war between who gets, if you collect the data, you get to use it, but nobody else does, or is there a value in sort of one version of the truth and then finding a way to parse out access to that data and use for that data wherever it needs to be applied. And I'm curious, you've probably seen this in spades, and I'd be curious to kind of get your thoughts about distributed versus federated versus, a single source of truth. What do you think?
Well, I think, at the end of the day, there needs to be a single source of truth when it comes to data. You need to understand what you've got, okay? But that doesn't prevent you from being able to distribute the data. And just like compute, which does much better when it's distributed, just talk to the Hadoop people and they'll tell you this, you can distribute data so that it can be more efficiently consumed. And again, there are tools out there that can help with this. I've also seen people write their own tools to do this. And so it makes a lot of sense to me, especially now that you have, stuff in the cloud. And so why not, if it makes sense, if we use Amazon as an example, regions all over the world that house data and compute resources. And so why not distribute the data where it would be used most? If you're a large global company and you know that, your European data is probably going to be consumed more in Europe than it is in the United States, then let's distribute at least the European part of the data to Europe. That doesn't mean it's not available in the U.S., but it just makes sense.
Yeah, it sure does. And it's possible now, and it's not
very
cost
much so.
prohibitive the way it probably was at one time.
Right.
So this question I kind of want to ask you, it's been intriguing me ever since I've been with Aerospike in particular. I think that it's really interesting because I see online transaction processing and analytics sort of merging. There's been some terms kicked around for what that is, but we used to, in the old data warehouse days, we used to have a transaction processing system that you didn't let any analyst touch because you didn't want to slow it down. And, the kind of the debate today is what's the difference between what we used to call analytics and today's use of the term like real-time decisioning or inferencing systems? Is there a difference? Is it the same thing? Is it OLTP and analytics? I don't know.
I think it's just another name for the same thing, frankly. And but it's what it all comes down to is speed. How fast can we make sense of all of the data that we're collecting? And the faster you can go, the faster you can monetize, and the better off you're going to be. That's your business model, right? And for the people in the public sector, they're not necessarily monetizing it the way we think of monetizing, but still they have to come up with a conclusion about something. And the quicker they can do that, the better off they are. That's their way of monetizing. So, I think marrying those things up it makes a lot of sense, and people have tried to do that over the years. And sometimes compute got in the way because it was too slow. That's really no longer the case. And in fact, it's only going to, Moore's Law is not dead yet. And this trend is going to continue. And so it's important as people are building out things like Aerospike and other tools that they do so with this mindset that these things are going to have to scale far beyond what we're thinking today. Far beyond. I don't think we can even imagine, say 15, 20 years from now, what some of this stuff is going to have to do. And some of you out there will say, well, Aerospike won't be around by then. It'll be some other new tool and all that. Well, I beg to differ because there's a lot of tools out there today that were around 50 years ago. And some of them have managed to scale up and some haven't, but they're still there.
So our grandchildren are going to think we're a bunch of Neanderthals 100 years from now.
That's right. That's right.
So here's an interesting question. We had an advisory board meeting a year or two ago, and one of the advisory board members asked an interesting question. It was, how has the use and handling of data changed in the last 2 to 5 years? And we used to think of getting insights from data that was static, after a lot of analysis and processing. You might make a decision where to build a factory, do some activity-based costing, looking at, your bill of materials and analyzing things to improve the business. But now it seems like we're trying to make data-driven decisions for events as they happen. What do you make of this sort of transformative element of the way data is being used today?
Well, it has to be done that way. A few years ago, we would do this static analysis of data, and by the time you could then understand what the data was trying to tell you, and then go build whatever it is you were trying to build based on that data, everything was outdated by the time whatever it was came online, whether that was a new building, whether it was a new computing system, whatever it was all outdated. And so we have to get into this mindset of, first of all, hardware has to be more throwaway than it is today. And that has some huge ramifications to it, not only from a, buying standpoint, but also from a, what do you do with that stuff as you replace it, from a recycling standpoint, say. But all of it in mind to do exactly what you're saying, is to dynamically analyze what's going on. You don't have, if you look at a news company today, New York Times, whoever, they're not taking data that they collated 6 years ago and then creating a headline today based on that data. But that's exactly what we were doing 20 years ago, when in the intelligence community and in the commercial world. So you have to be able to react to these changes in the data as they occur. And there's still certain things in life where you have to, you got to make a decision. So, for example, if you're out there, you're going to buy a new car, and you say, I'm going to go look at all the data on new cars and figure out what's the best car for me. You could do that forever because cars change all the time. But in that situation, at some point, you have to say, okay, enough's enough. We're going to buy this car, all right? And that'll be good for as long as we can tolerate it. And then we'll buy another car. Could be you tolerated that for 10 years at one point, and maybe now you can only tolerate it for 3 years because of the rapid changes that take place. But in the analytic world, this stuff has to be done in nanoseconds.
Yeah, that's very true.
And again, I just point to the trading floor, and you look at what goes on there, and these things are done in split-second increments.
Yeah, we used to, in the BI space, the business intelligence space, we would meet with potential clients, and we would say, hey, can you only imagine how valuable a better decision would be? And it was really tough for the decision maker or the buyer to calculate the return on investment from, quote, a better decision. Well, it's kind of interesting. Yeah. And you kind of wanted them to go, oh, yeah, it'll be worth a lot of money to me. So, I'd like to use your technology and I'll become a customer. But it's kind of interesting. We have clients that have things like recommendation engines, profile stores, and the like. And the inference engines, in many cases, are handling maybe as many as 1 million business transactions a second, which is just stunning. Now, so you could make the posit and say, well, what if every one of those transactions was potentially worth $200? And what if each one of the decisions was 5% better? So in theory, that would be $10. But if you did 1 million of them, if it's $200 and you make a 5% better improvement, that's $10. But if you did 1 million of them in a second, well, I guess that'd be $10 million. Yeah. So the margin is so thin, but the volume is so high that the outcome of using technology well can be massively beneficial to businesses, whether they're improving customer intimacy, whether they're trying to have a recommendation engine that people click through and buy something, or fraud. If you eliminate an extra 5 or 10% of the fraud, or you have false positives, negatives, and you eliminate those, impact can be substantial. So one of the questions that we occasionally get into discussions about is, if you're a company with legacy technology, and I'm sure you experienced that, over a 30-year career, there's a full life cycle of applications that have been built, databases that have been either built or populated. Is it better or easier to iterate your way to modernization, or just bite the bullet and do a complete lift and shift? Do you have any thoughts on that?
Well, yeah, and like most things, it depends. And so incremental improvements are good and proper for many, many things. But for example, if you're trying to move from an on-prem system to a 100% based cloud system, that's very, very difficult to do incrementally. And so, again, it all depends on what it is, and it depends on how well-formed your applications are and so on, and what kind of data they need access to. But I do a tremendous amount of strategizing with companies on moving from on-prem to the cloud. And so those things are better done in a well-thought-out manner, taking full advantage of all the resources that are in the cloud, versus trying to force fit your on-prem ideas into the cloud, which wasn't built for that. Yes, you can force fit it, but then it's not going to be as efficient and so on. I kind of liken it for the programmers in the audience. If you've ever programmed in ATL versus programming in assembler, or even, PL1 or Prolog or whatever, you have to think differently when you program in these different languages. You can use all the Fortran techniques you ever learned and program in any one of those languages, but you'll end up with very, very inefficient code. It'll work, but it'll be very inefficient. And so the same thing happens here with data analytics, with compute, revitalization. So it's a different mindset that you have to take on. And when you're moving from this notion of saying, well, I need to get the aircraft data expert and the automobile data expert in the room together and let them hash out, whatever the problem is. Well, why don't I just get two data scientists who their expertise is data? They don't care where the data comes from, and they can get together in the room because they're looking at all the data at the same time and come up with a better decision faster. So
that makes a lot of sense. It's kind of a complicated world for organizations with a lot of legacy applications.
Yep.
Yeah, we got time for one more question. I'd love to have you opine, as it were. What advice would you offer to large organizations that have a lot of legacy systems, and the senior management says, we need one of those digital transformation thingies? It's easy to say digital transformation, but it's another thing to actually have the staff that can build it and have a strategy. You've seen this probably dozens of times. What advice would you have to give to the audience on a topic like this?
Well, my biggest advice to people on this, and I get this question a lot, is find somebody that's been there, done that, who really understands the perils and pitfalls of doing it and the mistakes to avoid. And, absolutely build security into wherever it is you're going, as you go along. Don't let it be an afterthought. The worst things we see happen with some companies is that they, in their rush to get into the cloud, say, and they've done a great job of it and all that, but they kind of forgot security because that would have slowed them down a little bit. And now all of a sudden, I'm sure you've seen reports of this all the time. Here's this great big S3 bucket in Amazon that was left totally open to the public, and now a bunch of data got spilled. And it's because of an oversight. It wasn't somebody intentionally did that. It was an oversight, and because they weren't building security into things as they went along. And so you have to, as you're doing these things, just like your on-prem stuff has to follow a good governance model, so does your transition to the cloud, and so does your cloud operation. Have to have a rock-solid governance model that you follow, and that will avoid some of these pitfalls.
Well, that's great advice. It certainly is. So, Bob, I'd like to thank you for your thoughts and insights. I think this is, very timely and very appropriate. And I'd like to thank the audience for spending the time with us this afternoon. And thank you all very much.